The data center is really the engine of our digital world, but we think that engine is ready for a pretty profound transformation. Today, we're going to walk you through a new blueprint that completely reimagines this critical infrastructure, turning it from a resource consumer into a true community contributor.
So let's just start with this one big question. What if the very buildings that power our cloud, our AI, everything, what if they could actually strengthen our local water and energy systems? Seriously, imagine a data center that doesn't just serve the digital world, but also helps the physical community it lives in.
Well, this isn't just some far-off vision. We've developed practical, actionable patterns for building data centers that can give back more water and heat than they consume. And in this explainer, we're going to walk you through that exact blueprint.
Okay, so first, let's talk about the stakes here. Conventional data centers have a huge environmental footprint. Their cooling systems can literally evaporate millions of fresh water. And all that immense heat they generate, it's typically just wasted, vented right into the atmosphere.
And this slide really gets to the heart of the shift. On one side, you've got the old model, which is just a massive drain on local resources. But on the other side, our blueprint creates this symbiotic relationship. So instead of just taking, these facilities can become sources of fresh water and reliable, clean heat for entire communities.
So, how do we actually do this? Well, this isn't some rigid, one-size-fits-all solution. Our blueprint is actually made up of 3 adaptable models, and each one is designed for different environments and different needs.
Let's start with our first model, coastal hubs. The logic here is really simple, but it's so powerful. You co-locate the data center with a desalination plant. Then you use seawater for cooling, which is way more sustainable than using fresh water. And then, and this is the game changer, the waste heat is captured, it's upgraded with heat pumps, and it's used to help power the desalination process and supply district heating. The result? A hub that produces both data and fresh water.
Now, let's move inland. For our inland campus model, the big priority shifts to conserving precious fresh water. Here, the blueprint calls for using reclaimed wastewater, not drinking water, for cooling. When you combine that with super efficient liquid cooling systems, you slash evaporation, and the waste heat can be captured for all sorts of local uses, like warming nearby buildings or even supporting urban agriculture in greenhouses. And our third model is designed specifically for colder regions, where that recycled heat is just incredibly valuable. We call it Heat First. In this case, the entire system is designed from the ground up to recover heat at a higher, much more useful temperature. This high-grade heat can then be fed directly into district heating networks, warming thousands of homes during the winter when demand is at its absolute peak.
Now, underpinning all 3 of these models is one non-negotiable principle: transparency by design. The idea here is simple. Communities have a right to know how their resources are being used. That's why our blueprint requires public reporting of key metrics, all verified by independent auditors, to build real trust and ensure accountability. So the models are clear, but how do we actually make them a reality? Well, the blueprint lays out a really practical path for implementation. This isn't just theory, it's a step-by-step guide to get us there. The path really starts with smart site selection. From there, a strict cooling hierarchy is put in place that always prioritizes non-potable water sources. And crucially, heat recycling isn't an afterthought, it's planned from day one. It all comes together with a real commitment to water stewardship and strong community agreements that tie financial incentives directly to verified public benefits. And the economics of this whole approach create a true win-win situation. Cities get real, tangible benefits like low-cost water and heat, and in exchange, they can offer predictable permits and grid access. Operators, meanwhile, get financial incentives and stability, and in exchange, they deliver those community benefits. Suddenly, public and private interests are perfectly aligned.
Look, this kind of transformation is going to require a collective effort. But the good news is everyone has a role to play in speeding this up. Here's how you can actually help.
If you're an urban or regional planner, you hold a really important key. By making heat recycling and sustainable water use a prerequisite for any new data center permits, you can set a powerful new standard for your entire community.
And for all the engineers and system designers out there, we need you to share your knowledge. Publishing open-source designs for these advanced cooling and heat pump systems will help the whole industry adopt these practices so much faster.
For you city leaders, the message is to use your leverage. Structure your incentive programs so that tax credits and other benefits are directly tied to transparent, verified performance on water replenishment and heat delivery. No results, no rewards.
And for everyone else, your choices really, really matter.
You can support local district energy projects. And when you choose digital services, ask if they're transparent about their water use. Your voice as a consumer can drive huge change.
Ultimately, this all brings us to a fundamental decision, right? It's a choice about the kind of infrastructure we want to build for our future.
This is what we believe at our core. We have to move beyond this old model of data centers as just resource liabilities. They can, and they absolutely should, become powerful assets that help our cities become more sustainable and more resilient.
The technical patterns, the implementation path, it's all laid out. The blueprint is here. So the question for all of us now is, will we make the choice to build this better future? Thanks for joining us.